Okay, welcome to the second recording of the Go series. Again, just like the last one, it's kind of just freestyle. So this is going to be episode 2, and we're basically talking about the project structure. So for the series, it'll kind of go in the order in which I'm kind of doing things. So to start with, obviously, like project structure, kind of setting up the project, finding proper packages, dependencies, and whatnot. And then after that, I will start actually working on the code, modulating it, and then once there's an actual thing, then we go into the build process and then the distribution. So that's kind of the idea of how the series will flow. So yeah, let's get started. Okay. So what is a project layout? So it kind of describes how different parts of a project will interact with each other. And a very core concept of a project layout is the idea of modularity, where a specific, typically a folder or file is used to handle a specific function, and that their interactions between each other are abstracted away into into just general function calls, so that the underlying mechanism in which to do the certain task becomes not in the scope of the main project or the main file. And also we're going to talk about the requirements. So here's my laser pointer. So here's what we're going to be doing right now. We're going to be getting into reading documentation, basically. So here is the first file whenever you run the go init command. So that initializes a folder as a project. So the difference between a folder and a project is that a project is able to have dependency tracking and is able to be replicated across and then eventually being published as a package into whatever registry. However, for mine, I will likely not go into a registry because that has a specific format. This is kind of how I structure my passcode, so in TypeScript. So first is the go.mod/go.sum, which I'll talk about in the next slide. But these are basically responsible for handling dependencies. And then all the actual code, to me, is thrown into the source file. So the source file, then you can see these subpackages, which I'll describe next, and the main.go file. The main.go file is our entry point into the project. Okay, so next slide. So what is the go.mod/go.sum file? So it's used for packages, you can see right here, and for dependency tracking. So for each package, there's also a version number by it, because different versions can break compatibility. So it's important that whatever package manager is able to use the specific version in which they were first tested with or used with. And then, for example, it also right here, it has the Go file or the Go version, so that whenever the project is able to understand which Go version, because within different versions of the language, parts of the structure, the syntax, or even the project dependencies gets different. And then right here is your first line. So this describes it as a package. So that's what makes this folder basically a package, is this definition of module. And then this is where you put in the tag. So I kind of did this wrong, because it shouldn't be just a string, but rather it should point a lot to a repository. So if you look at all of these, which are the packages I've installed so far, they have the GitHub to the repository in which the module is in. But this can technically be anything you want, such that it's able to be accessible. So it doesn't necessarily have to be the GitHub, and I don't have a GitHub project repository for this yet. And yeah, so you can see here, and then there's difference between indirect and direct. And indirect dependencies are dependencies that your direct dependencies require. So your indirect dependencies get installed with your dependencies, so whatever package you are dependent on, those packages have to be dependent on other ones. And that can also be seen in the go.sum. So the go.sum is an even more detailed list than just this. This is a more high level at it, because the go.sum file actually looks at the dependency analysis and goes through and sees how each package and sub-packages and all of their dependencies and so on relate to each other. Okay. So here's your entry point to your file, which is the main.go. This can actually be anywhere, because the main.go it doesn't have a specific location. Like it could be in source/main.go, but it doesn't have to be. It can just be in main.go or even somewhere else, because the only thing that's identifying it right here is the package. The package main, this is what identifies it as the entry point. And you can only really have one of these, one package main files, or at least at the same level directory, because any subdirectories, which I'll show next, acts as sub-packages and have to be defined as a sub-package and can't be defined as the main package. And then within the main package requires the main function. So this is the actual entry point. This is what's being ran whenever your project gets set up, or whenever you compile and build your project and then run the build. So whatever's in here. So here are the imports. You can see our importing of the packages. So you can see right here, that's the GitHub syntax I was talking about here. So this is specifically depending on a package called Cobra, which is right here. And you can see it being used down here. So basically, Cobra allows a Go project. It's basically a very high-level wrapper for handling command line interfaces, right? So because you have commands, you have flags, you have versioning, you have all of these, you have sub-commands. So Cobra is able to make this a much more simple experience instead of having to re-implement basically everything from scratch. So it's able to print out a nice output whenever the user ends up using the project. So you can see right here is the use. So this is kind of saying what is the command. And you can see right here it gets attached to the root command, which I didn't show in the screenshot, but basically the root command is just the ddnsu command. So if I run ddnsu version, it's going to run this function right here. And then you can see this utils. That's importing from my source/utils, which we'll look into next because I define generic functions in there and the usage of the generic functions. And you can also define the argument length, a short and long description. So it has a lot of power to make flexible command line interfaces. And right here, you can see the assignment operator. So that's kind of how Go assigns variables, which I'll talk about more when we actually get into more deep code analysis in future episodes. So here is the concept of sub-packages. So within those sources, if I go back to right here, you can see within the source file, I have these 3 folders, which will probably be more. And in these subfolders have their own Go file. And then you can see right here the package command is no longer, or the package declaration, it's no longer for the main because it's no longer on the same directory level as it. So it must use the subfolder, which is the utils folder. So it's going to be defined as package/utils. And here I can have my own functions, my own imports, and then my own functions here. So right here I have a function that basically it's in the network.go function, and it tests whether or not the system has internet, right? So it's just going to take a net request and it's going to check if the network's okay. And it's just going to connect to a random example website. And if it's okay, or if there's an error right here, the net okay, if there's an error, then we're going to print the error and then return false, meaning that networking, something happened, right? It could be still working and say this is blocked or whatnot, but we're just going to assume that if there's an error on a response to this very simple website, then there is a problem with the networking. Otherwise, we're going to check the status code, whether or not it's 200 or else, and then we kind of just return that. And then within Go, so in TypeScript, we have the export syntax where you can write in front of a function, basically export, and then whatever is in front of the export is accessible by other files. However, in Go, this is more opinionated. There's no export keyword, but rather you have to define it. Define the function with a capital first case letter if you want it to be exported. So anything with a capital first letter is automatically exported. Anything without is not exported. And there's no workaround to it. It has to be within the syntax rule. And it's very opinionated, but I am getting used to it. And I think it's okay, but I'm not very used to this basic casing style of use, because normally I use camel case, which is where the first word is lowercase and then you start capitalizing after. And then here's a second example of a sub-package. So this is the commands, and then in here, so I have to define it as a package commands. And then here I have other functions that are used. And you can see actually the difference. So these functions here will not be exported. These functions are only supposed to be used internally within the function. And there's more lines. This is just an excerpt of it. And that these functions are basically used inside of other functions that actually do end up getting exported. So not all functions have to be exported. And yeah. So here's what's currently done, and it's practically nothing, to be honest, but I had to put something. So we have the project structure. So my idea behind the project structure here is within the services. So my original project could use Cloudflare and Vercel, and so far my goal is to at least get those 2 services running up. So all of their logical code, such as listing DNS records, adding DNS records, checking the authentication of their tokens, that's all going to happen in here. And then the main.go and the commands folder is all going to wrap it together, so like the login and whatnot. And to go back, so the configuration file, I didn't show it here. I'll show it in the next episode, but basically the structure of the configuration file, which will be a TOML structure, which is really simple, and there's already packages on Go that I'm learning how to use to read those TOML files and create a actual accessible object in memory. And the utility functions with the printing and formatting, so you can see it right here. So this refers to the utils package that we talked right here. And this function right here just prints a formatted string on a new line, because the other built-in in the standard library is just printing a formatted string, but it does not automatically insert a new line character. That's all that this function does. It's nothing really special. And the idea of a CLI, so yeah, using, not Anaconda, Cobra. Anaconda is a Python thing, so don't forget that. And the utility functions, and then we talk about, so what has to be done or will be done is the service, which I just talked about. Network requesting, I'm using the built-in Go/HTTP module, which has its own caveats that I'm trying to figure out. And then just globally accessible variables, because right now, in a functional sense, every function requires an input of the token or the configuration file or whatever to do anything to it. However, that might be too deep into the philosophy of functional programming for my project, because I do need globally accessible variables like tokens rather than having to pass them within each function, and a lot more things like color. Right now the command line interface has no color, and I like colors. So yeah. So this is my bye-bye. This is Dr. Pepper. I love Dr. Pepper. Not sponsored or anything, but I just love Dr. Pepper. Yeah, I need to go actually eat. So take care.